In the first video, I showed you how you can quickly and easily read data into R and make your first plot. In this video, I'm going to show you a few minor changes that you can make to your code in order to turn that first plot into many more, including violin plots. I'm also going to deal with an issue that comes up a lot, which is how to order chromosome names correctly on your axes. That's something that took me hours to solve the first time, but then I found a robust solution that you can apply very easily right now. So that should hopefully save you some time. So let's get started. Now I'm going to show you some quick examples of the kinds of plots you can make in R. So first let's read in the library ggplot. That's going to enable us to do all the plotting we're going to do. We then have a file name, we're going to read in some data, and we're going to set the column names. All of this was covered in the initial video called R for Biologists, Your First Plot. And if you've seen that video, you'll notice that this time we have a lot more columns, and that's to give us a little bit of extra data that I can show you how to plot that. So one of the things we can do is to make a simple bar chart. And so that's going to look something like this. And so one of the most annoying things in this plot, it looks very good except for on the x-axis we have all these chromosome labels, and some of these are just those alternate chromosomes that you don't usually want to put in your plots, even if they are important for sequence alignment and things like that. So this is a really quick way of dealing with that. It's basically saying I want to replace the column in my data called chrome. That's this column over here, right? And we're going to replace that with a factor. So it's already of a type called a factor, which is something where you have all these different names like 6 and 7 and 8 and so on. Those are all the chromosome names. And they all are not just words and not just numbers. They are of a special type where they kind of have an ordering to it. So right now they're ordered as 1, 10, 11, 12, and then only later do you get up to, after 19, you get to 2, and then 20 and 21. That's not really the order that we want for our chromosomes. So what we can do is reset this ordering using this levels thing right here. So you say, I want a factor, and this part is exactly the same thing as this part. So you're basically inputting it and then replacing it with, you're replacing my data column chrome with a factor where you transform my data column chrome into having these new levels, which are the categories of information you can have in here. And here we're making a list from 1 up to 22. See that right here. And then there's also an X, Y, and mitochondrion. And so that's basically saying that's the new ordering that I want for my chromosomes. And if any of them, like these GL something down here, the alternates, if they're not in that list, they're going to be called NA. So I'm going to run this and show you, I'm going to run this first, and then show you what the plot looks like now. So now we have the chromosomes ordered correctly, and at the end we have the NA. If you notice, there's no Y in here, and that's because we didn't have any rows that had a Y in them, and so that's not going to be plotted at all then. And so that's what we have there. So it's kind of fixed that issue, which is one of the most annoying things to deal with when you're plotting biological data. So that's one of those tricks that took me probably a few hours to figure out how to do it correctly first, because there's so many different ways to solve the problem. But this one is really the fastest. I was trying to look for a way to solve it within ggplot, but it's actually easier to just change the data itself. And when I say change the data, I don't mean it's going to write anything to the original file you got the data from. That's completely untouched by anything we're doing in R, so that's not going to be affected. Other things we can do is make histograms, but first let me take a look at this bar chart right here. So the data that we used is, we said that the x-axis should be the chromosome, and the fill, meaning the color of the bars, is going to be based on the type, which are these variants like contraction, deletion, expansion, insertion. And so that's like the data that we told it to plot, and it made a bar chart from it. And the way we told it to make a bar chart is we said geome bar. But this one, when we plot a histogram, that also says geome bar. Let me run that for you so you can see what it looks like. And here, the x-axis is now size, because we told it x equals size, and fill equals type. And so the y-axis is still a count, because you didn't tell it what the y-axis is, which is good. So now it's a histogram, and it's just based on the actual count of how many rows in your data have each size and each type. So that's pretty awesome. And so now, because the x-axis is now a numerical variable, which is size, whereas before it was chromosome, that means that before it was a categorical variable and it made 1 bar for each category of chromosomes. And here we have size, so now it's going to make it a histogram instead. But both of those are geome bar, because they're both bar charts of some kind. And now the box plot is another kind of plot that we can make. This one looks pretty cool. So here we said that the x-axis should be the type. You always have this AES thing. So you do like ggplot, my data, whatever you named your data when you read it in up here. See that? And like we keep looking at my data. You can see it highlights them all down here. So the box plot, we have my data, and AES describes what each part of the plot is going to map to in your data. So the x-axis is the type. See, x-axis has the types on it. And then the y-axis is going to be the size. That's up here. And then the fill color is the type. And so that matches the x-axis now. But if we took that out, then they would just be white instead of having these nice colors. So I like to at least have the colors in there just so it looks a little bit better. So that's the box plot for you. So notice how simple it is to make a different kind of plot all of a sudden. The only thing you have to change is what's inside the AES just to make it make sense with that kind of plot you're doing. And then you go geome box plot instead of geome bar. And to change from a bar chart to a histogram, the only thing you had to change was what the x-axis is showing, whether it's categorical or numerical as a variable. Here's another kind of plot that we can make. And this one, notice this first part is exactly identical to this part. So the box plot and the violin plot have exactly the same kind of data in them, but it's going to look very different. So notice how the plot changes now that I make it into a violin plot instead. Beautiful. And so this one has more of a density distribution, which is kind of cool and shows you a bit more than what the box plot does, which is more focused on the mean and the interquartile range and so on. Whereas the violin plot kind of shows the shape of the data a lot more. One fun trick is that you can very easily make the x-axis into a log scale. And you just do that by doing scale y log 10 with parentheses. I'll pull this over a little bit here so you can see the parentheses sitting there. And so if we run that, now instead we have it on a log scale. So you can see it has 10 and then 1,000. And now our violin plot is much more spread out, which is really nice. So you get a better idea of the distribution that's going on here. Another thing we can do is a density plot. And here I can do a density plot with just part of it here. So this is what it looks like, but then they're overlapping each other. So what I like to do for density plots is to use this facet grid, which is really awesome. And what that does, notice how we're always doing this plus, like we're adding to it. We do the same thing for the log scale here. So you're simply saying, like, I have this plot, and then I'm adding the facet grid to it, and the facet grid is going to separate them, and you're saying I want to separate by type for the rows. So I want like rows that are made by type, and then I don't want anything for the columns. But if you put something else here, you can do that too.